Hello and welcome back to another episode of my tutorials about building our home cockpit to communicate with Explain. The purpose of this tutorial is to communicate our physical equipment, physical hardware such as knobs, switch, rotary encoders, LED, LCD, 7-segment, and so on to our flight simulator software, which is Explain in this case. We are going to create some hardwares, for example, a rotary encoder for our heading knob of the Autopilot. We are going to rotate a physical heading knob here, and when we rotate it, the command goes to the Explain, and the software will decode the command and rotate the heading knob inside the airplane, inside the Explain for us. This is very interesting because this is the first step and one of the main primary steps for creating your own home cockpits. So let's get started. In the last video, we talked about the different approaches and different methods available for us to connect, to communicate Arduino and SimVim. And we also talked about why we choose Arduino. You can use any other microcontrollers you have, such as Raspberry Pi, or maybe a custom 80 Mega or AVR microcontroller. The goal for this tutorial is to find the easiest and quickest and also the cheapest method for this purpose. So we choose Arduino, and we talk about different methods that we had, such as using UDP communication through SDK or through MATLAB. And at the end, we came to the conclusion that using SimVim is the best solution and the quickest solution for us. For those of you that you haven't watched the last video, I suggest you that pause this video and go to the last video. I also put the link in the description for you. So if you watch the last video, you get an idea that what we are going to do, what are the problems, what are the considerations, and why we chose SimVim. So if you're ready, let's get started. Just to have a quick review about what is SimVim. We talked about it in the last tutorial, which is here. SimVim is a platform, is an interface, better to say, that creates everything for you. You don't need to type a single line of code when you're using SimVim. SimVim is doing everything for you. SimVim is taking care of hardware problems, hardware communication, the commands, interrupt handlers, and every other consideration that you have to be aware if you want to code this this program for yourself. So you can say that SimVim is a magical solution for this purpose. And SimVim is open source, has great documentation, and is constantly improving. So if you come to the SimVim website after 2 weeks or 3 weeks, you find that there is something new, a new version has come and some improvement you see. And also in the last video, I told you that there are very great videos out there in YouTube about SimVim. For example, Paul's flight deck is available. It's one of the best videos out there. But since Paul has published his video, many things have changed, or better to say improved in SimVim. So I'm going to publish another video just to have a better and updated tutorial. Okay, let's get started from zero, from scratch. What do you need to start? First things, you need an Arduino Mega. If you have, that's good. This is the board, Arduino Mega 2560. If you have, that's great. If you don't have, it's very cheap. You can order it with, I don't know, $10 or between $10 to $15 for the fake boards, and more expensive for the original boards. I have the fake board here, and it's very cheap and okay. Next, you need Explain. It's obvious, you need Explain, and you then you come to this website. I'm going to continue with using the website documentation, so to make you to show you that the documentation inside the website is very great. So there is nothing out of sequence you need to do. Everything is step by step described here. First, you can read some demonstration about how SimVim works. Then go to install first start. Sorry. Okay, As I told you, you need an Arduino with ATmega2516. Then you need to download the SimVim Cockpit plugin. SimVim has two parts. One part is integrated with Xplane, which is a plugin, and one part is available to you online, which is called SimVim Configurator, and we talk about it later. So the first step is to download the SimVim Cockpit software plugin, but there is no link in this page. At least I didn't find the link here. So go back to the main page, and here's the link. Download SimVim Cockpit free. You can get it from the Patreon blog here. And don't forget to, if you can, do some donation for SimVim Cockpit people. They are doing very great job, and they need support to continue their jobs here. So if you can, don't forget to donate them. This is the Patreon blog, and the latest version that at this time that I'm recording this video, which is 7th of September, this is it, version 0.942, and you can see the changes, but simply download the latest version here. I have already downloaded here. It's here. Open it. You find a folder here which is called SimVim, and there is a plugin inside it. If you have watched my video about the plugins, you know what exactly this folder is. So get back here and copy this folder to Xplane resources. If you remember, you go to your Xplane main directory, which is on your own drive, games Xplane 11, and you go to resources, and you go to plugins, and you just copy this folder here. SimVim, I already copied it here. Okay, done. First step done. Let's go to next step. Okay, next step is follow the getting started procedure that I'm going to tell you. Next step is using connecting the Arduino to Xplane and program the board. So I'm going to run my Xplane. Okay, here we are in a beach baron in Payam International Airport in Iran. That doesn't matter at all. So in this step, you have to connect your Arduino using USB cable to the computer. When you connect it, go to your plugins. Before connecting, go to your plugin, SimVim Cockpit, and if it's the first time, which is in this case, click on firmware upload. You need to upload the SimVim firmware on your Arduino. And by the way, if you haven't used Arduino at all, maybe your computer doesn't have the driver for the Arduino. So if in that case, if you didn't have the driver for that, go to the Arduino website, which is easily accessible through the Google. You can search Arduino and go to Arduino website and download the driver. Easily download the driver, arduino.cc. You open it and download the driver for your operating system. But usually your computer may recognize the Arduino just the time you connect the board to computer. Okay, here. Click on the next, and remember, don't connect the USB to the computer, because the SimVim, this is the way that SimVim finds what COM ports you are using for your Arduino. So disconnect the Arduino from computer, click next, and now connect the Arduino and wait for the SimVim to identify your COM port number. And click detect port. This is COM24, and the controller type is the master board, because we only have one controller here, and Mega 2516, and we are using serial. If you wanted to use Ethernet breakout ports to communicate with your computer, you would check the Ethernet as well. Then you click on upload, and the computer will start to programming the Arduino, and the two RX and TX lights. If I want to show you, two RX and TX lights start to blink very fast because it's programming the board. After it finishes, you see the upload atom completed, and everything is done. You can close this, disconnect the Arduino, and connect it again. And again, this time you go to plugins, again SimVim Cockpit, status, and wait for the SimVim to identify your board. If, just like here, if it didn't recognize your board, just go to plugins, SimVim, and click on hardware reconnect. And again, wait for here. That's it. USB SimVim Cockpit firmware, and our board is identified correctly, and also the RX light starts to blink very fast. Okay, that's done. We don't have anything to do with the configuration now here. And now we are going to get out of Explain and come back to SimVim websites. As I told you, another part of the SimVim is the Configurator page, which is online available, and it's constantly changing and improving. Here, this is everything you need to configure. You see there is no line of coding here. Everything is just clicking and setting the configuration without any coding. So what this do? You see you have all the pin numbers available in Arduino 2560 here. Here you assign the commands and it assigns the task to each pin. For example, you want to assign the LED for landing gear condition to, for example, pin 10. Or for example, you can assign the Autopilot, Engage and Disengage to pin 4. This is the page you do all the setting here. And before going further, you click on master board, and click on serial USB because you're going to use serial USB here. There are some guides here, but the main things you need is parameter tables. These are all the things that you can assign to the physical hardware that SimVim can do for you. For example, you see that flight controls, engines, anti-ice system, lights. For example, in lights you can see landing light switch on. This means that you can assign a switch for this command, for this task. And for all, you can see there are lots of them. You can do all this task. You can have hundreds of buttons and switches here. And also you have the layouts for the popular aircrafts. For example, Cessna 172, I don't know, Boeing 737. You can click on, for example, overhead panel. And okay, this is the overhead panel for the Boeing 737. You can, if you hover your mouse on this switches, you can see the suggestion comes and say, for example, flight control A or battery 1 switch. This means that if you can assign a two-state button to this switch that can turn on and turn off the battery 1. Or for example, here you can see a gauge, which is APU EGT gas temperature. This is an indicator. If you click on that, you can have the different options. For example, the more interesting part is this one, a step motor and the servo. As I told you in the last video, you can connect a stepper motor or a servo motor and connect the exiting shaft of the motor to the needle on a printed page. That will work just like the gauge. Maybe on the next video I will do that for you, but it's very simple and straightforward. There is no need to code or configure anything. SimVim will do everything for you. Okay, what we are going to do in this video is much more easier than this stuff. We are going to go to Autopilot and MCP panels and go to, for example, this one or this one. Doesn't matter, all of them are the same. For example, this one. You can see we have the command for the heading knob, heading engage and disengage, and autopilot engage and disengage. This is the main purpose of this tutorial. I'm going to have two buttons, one rotary encoder for these three tasks, and also an LED, an onboard LED of Arduino for this small light here. This small light indicates that if the heading mode is on or off. Okay, that's all the configuration we need. But Before going further, let's talk about what is Rotary Encoder and Pushbutton and how to connect them to the SimVim. Just simply go to the Google and search SimVim Rotary Encoders, and this page will come for you. In the first paragraph, you can find some theoretical details about what are the encoders and what are the purpose for them, and the theoretical concepts behind them, how are they working, what are the details, and what are the types of the encoders. But all you need to know is that each encoder has 3 pins. Some basic encoders have 3 pins. And when you rotate the encoder, the details of the encoder, these places will change, these places will move. I'm going to show this for you in oscilloscope just a few seconds. But you don't need to know anything about this. Everything is going to happen for you inside inside SimVim. So everything SimVim will do everything for you. Don't worry about that.
Okay, this is exactly what is happening with the encoder, rotary encoder, with the signal process using the oscilloscope. You can see the channel 1 and channel 2 is connected to the both A and B, and also the ground wire. You can see by default there are some waves from both channels, and they have phase shift with each other. But when I rotate it, something's happened between them. And when I again release it, again the waves came back to the last state. Again when I rotate, one of them is just changing, and when I rotate this way, again changing. Okay, this is exactly how rotary encoders work, and the Arduino will understand what is happening and how the rotary is being rotated using processing these waves, wavelength, frequency, and the phase shifts. We don't need to know about this stuff really. It's just nice to know for your own if you like this. If not, just skip this part and continue with the cockpit preparation.
But there's one thing to consider. There's only one thing to consider. Don't buy special and branded and expensive encoders. As you know, there are lots of encoder breakout boards, such as this one, which is very popular outside. These boards won't work, at least without any modification. They won't work because they have some resistors. If you look at the back of this board, there are some resistors, pull down or pull up or any other things inside this board. And this is not a raw signal. SimVim needs a raw signal of the encoder, so don't buy expensive encoders. Just buy some very simple and cheap encoders like this. But if you have this one, don't worry. You can still use it with some modification that I'm going to show you in a few seconds. All you need to do, you have two options. First of all, you can disconnect, remove the encoder from the board. Just unsolder these pins and remove the encoder from the board and throw away the PCB. Or if not, you can remove these 2 resistors. Very simple process using soldering iron. You remove these 2 resistors, and you are not going to use these pins. You are going to use the raw exit of your encoder. I'm going to show you how I did it in the video right now.
This is the breakout board for KY040 that I told you about. As you can see, I didn't remove the encoder from the board, so I decided to remove these 2 resistors, R1, R2 and R3, and also R1 if you had on the board. Remove these resistors, so there shouldn't be any other electronic components on this board except for this rotary encoder. And also, you see, I didn't use the data and clock pins, which will be usually used with this board. I didn't use these 2 pins. Instead, I connected these 2 wires to the pin A and pin B of the rotary encoder. You don't need to connect the middle one, which is the ground, because this ground is already connected to this ground pin. So I use this ground pin header board for grounding all the boards. There's only one thing more about this wire, which is switch button, and that's because this module has a rotary encoder and also a push button inside it. So if I press this, you see a ticking and also a movement. It is because this board has also a push button embedded inside of it. So this one is the connection for the pin of this push button. So that's all about it. You need to desolder these two resistors, connect these two wires to the pin A and pin B of the encoder, and also connect the ground and the switch to your microcontroller. You don't need to fit a positive VCC to this board at all. You don't need that.
Okay, now that we know how to use the rotary encoder, the next thing is the push buttons. So I'm going to search SimVim push button. This one is very easier than the last one. As you know, the switch push buttons just have two pins. They're either connected or disconnected. Very easy. Again, you have the theoretical details about them and the modes, different modes of them, and how they actually work. You can use this page to know more about the push buttons. But push buttons are very simple. They have two pins and they are connected between a digital input of the microcontroller and ground. Okay, this is the this is the board that you should build for your Arduino. You see, we have two push buttons and one rotary encoders. Rotary encoders, as I told you, has three pins. The middle one, usually the middle one, is the ground wire, so you connect it to ground, and the other two goes to two of the digital inputs of your Arduino. For example, I selected 2 and 3 here. This is everything you need to do with the rotary encoder. Next, you have two push buttons, as I told you. The first one is for the heading engagement and disengagement. As I told you, one of the pins goes to ground, and the other one goes to one of the digital inputs, which is, in my case, it's pin number 4. And for the other one, I selected the, again, pin 5 for autopilot engage and disengagement, and also the ground here. This is the board that you should be creating. And I'll show you how I did it in real Arduino right now.
Okay, this is my connection. This is my Arduino connection. This is the exact connection that I showed you in the video. As you can see, there's an Arduino Mega 2516, a KY040 with desoldered resistors, and the push button here. This is exactly the same with this one. Okay, so what I have done is I connected the pin A and pin B of the rotary encoder to pin 2 and 3 of the Arduino. I connected the ground wire, which is this one, to the ground wire of the Arduino, and I connected the switch for the heading engagement and disengagement of the board to the SW pin of this module, and I also connected a push button here between the pin ground and pin 5, I guess. Yes, pin 5. This one is for autopilot engage and disengage. This one is the rotary encoder, and pressing that will engage and disengage the heading for us.
Okay, now that everything is ready and you know how to connect the hardware side, now let's get back to software and do the configuration. First, click on the autopilot heading set. You can also select this one from the parameter table as well. You select on this, and we have only one option, encoder, which is select first controller pin. As we decided, we connected the encoder to the pin 2 and 3. So I will click on the pin 2 and done. Very simple. You can see in the last version you had some options here for the acceleration and different type, but in the new version of the SimVim configurator there is no options right now here, and I don't know why, because those options were good, but right now there is no options here. So you just click on the pin 2 and everything is done for you. The next step, which is heading engagement and disengagement. Simply click on that. Again, you have only one option, which is using a button. It says select direct or multiplex input. We are not going to talk about multiplex inputs here. Maybe in the next videos. Multiplex inputs are a method that gives you a lot more pins to work. But right now we don't need them. We are going to connect directly to the Arduino. So what pin? As you remember, we selected the pin 4. So I click pin 4. Autopilot heading is engaged. Engagement is assigned to pin 4. And autopilot engage and disengage. Again, I click on this and click on pin 5. Done. Very simple and fun job. And the last one, this is the LED lights for autopilot heading on and off. I'm going to click on that, and again we only have one option, which is LED, and I'm going to connect it to pin 13 because you may know that the onboard LED of the Arduino is connected to pin 13. That's done. Everything is done here and we don't need to do anything else. No line of code. Okay, now you click on save and a file will be downloaded here. You can see a data file, and there is also let's forget this one, the last one. This file may be considered as a harmful file for your computer, but it's not trusted. So you click on keep, and the file is downloaded. Next step is to go to the plugin folder of the explain, the folder that you copy to your explain folder, which is we just copied a few minutes ago. Resources, plugins, SimVim. You should copy this folder, this file, to the main folder or this file. And don't forget to delete the last file, which is data.cfg. Delete the older file and rename this one if it has anything else. And this is data.config file here. Now everything is ready. All we need to do is go into our explain, which is here. This is our pitch baron 15, and I'm going to go back to explain, but before continue, go to SimVim, status, reload configuration, so your new configuration file will be loaded. Then connect your Arduino to the computer. If you will lucky, it will be detected automatically, but sometimes it's not. Just like now, go to plugin, SimVim, hardware, reconnect, and wait a few seconds, and here we are. USB is connected, and everything is working. Right now, just first let's start with the rotary encoder. This is rotating. Autopilot engage and disengage is working, and heading engage and disengage is working. So I'm going to show how it's working from outside view from our camera right now.
And finally, the moment that we were looking for, this is our explain, and this is our first home cockpit board. First of all, let's work with the rotary encoder. As you can see, when I move it, the heading bar of the encoder is rotating. You can see the small orange things rotating here in both directions when I rotate this one. And when I press this encoder, because there is a push button here, the heading mode will engage and disengage. You can see the indicator for the heading mode is activating here and disactivate when I press this one. And the last one, which is autopilot engage and disengage. When I push it, you can see the autopilot engagement indicator here, and when I click it again, autopilot disengage, engage, disengage. Relatively simple. You see everything is working just as we expected, and with very simple steps using SimVim. So if you have any questions about this process, please feel free to ask. And sorry if the quality of the tutorial is not very good, because I have limited supplies. I am very busy with my university and work, so I don't have really free times to make the tutorials ready and make the tutorial more beautiful. So sorry for that, and if you have any suggestion for the next videos, next tutorial, if you need anything, if you didn't understand some part of this video, just feel free to ask me, and I will post the next videos about the topics you want. And if you have any question, you can ask in the comment, and if you want to know more about these topics, please like, subscribe, and give me motivation for this purpose. Thank you for watching. Have a great time with Explain and Arduino. Goodbye.